I am coming to you from my place of peace, my sanctuary, to talk to you today about electromagnets. There are two kinds of magnets that we study. We study permanent magnets and we study electromagnets. Permanent magnets are things that generate their own magnetic field. Electromagnets are something a little bit different. They're things together that if you separate the pieces out don't have their own magnetic field, but with certain power and with some elements that have the properties that exhibit magnetism, we can create a temporary magnet known as an electromagnet. For this, we need to create what's called a solenoid. For that, we're going to use copper wire. We're going to need some connectors, which I have right here. We're going to need a source of power right here. And then the very important thing that we're going to need is we're going to need to use something that exhibits properties of magnetism without being a permanent magnet itself. Now we have three elements on the periodic table that have properties that are strong with magnetism. We have nickel, we have cobalt, and then we have the one that we're going to use today, which is iron. And what we're going to need is a core that is made of an alloy called steel that is made with iron. So let's go and find ourselves a piece of iron. And when we're looking for things to make our core with, remember we need a high concentration of iron. And while we look at things like some old screws or possibly even carriage bolts, these are not quite what we're looking for. Those are stainless steel, galvanized steel. Up here we got galvanized bolts, we've got stainless steel. Those don't have the magnetic properties that we're looking for. We need something with a high concentration of iron. And we're typically going to be looking for maybe older stuff. This is a great bolt right here. I would love to make an electromagnet from this, but it's just, that's too big for what we're doing. I don't have enough power, electrical power, to run that through that. So let's look at some more just old tools to see if we can find something that would be good. There's nothing in there. Hole punches. This is very old. Real old tools have really good steel in them. It's a little bit too big. But this looks like it's going to work just fine. All right, let's talk about a little bit about magnetism. All matter is made up of atoms of different elements. These atoms contain a nucleus, which is a proton, neutron, and electrons. And the proton and the neutron are in the nucleus, and around it is an electron. An electron revolves around the nucleus. Electrons love to gather in pairs, and they rotate. And when they do so, they rotate in different directions. They don't both do this, and they both do this. They rotate in different directions. And because they rotate in different directions, they kind of cancel out their magnetic properties. Now, sometimes these electrons in certain elements will be traveling in different rings, and they will be single electrons, and they'll either be rotating this way or rotating this way, or a combination of the two. In order to generate a magnetic field, you need to put electricity in them, and that forces these single atoms to all rotate in the same direction. Now, there's only a few elements, we've already talked about this, that have the strongest magnetic properties, and that is iron and cobalt and nickel. Iron specifically has 4 single electrons in it that if you put enough current through it, electrical current through it, all 4 will start to travel in the same direction. And they're singular electrons going in the same direction. That is what generates your magnetic field. Iron is one of the best materials to make an electromagnet. So this right here, of course, steel contains iron in it. Even though they have magnetic properties, they're not magnetic themselves. We have to generate that magnetism by running our current through it, through a solenoid, which is going to be, again, our copper wire. So let's get started. What we do need to do is first make a solenoid that's going to go around this. I got some additional materials here. I got some electrical tape, some clippers, and I do have some sandpaper. And what the sandpaper is going to do is this copper wire. Look at it right there. It's not quite the color of real copper. It's because it has a coating on it. We're going to have to get rid of that coating, and we're going to use our sandpaper here to get rid of the coating. So let's get started. So what I did was I added a little bit of electrical tape down at the end of this so that I can get this to stop. I'll show you how that works. I'm going to wrap this around a little bit, and then I'm going to push it down, and see this electrical tape is going to stop it right there. So I'm going to continue to wrap around, tightening the coils every now and again. I want those coils nice and tight. If we wanted to make stronger electromagnets, we would need either to make more turns with this copper wire, or get a bigger power source than what I have here, which I have a 6-volt battery, which is pretty weak. But we should be able to see something. So we're going to continue to wrap this and then push the coils tighter. And the reason why we have, of course, one here and then we're going to have one at the end is because, like a magnet has poles north and south, we have a positive end and a negative end electrically.
So continue to wrap these up. Wrap it up some more. So what are electromagnets?
Magnetism itself has been studied for thousands of years. The ancient Chinese and both the Greeks and the ancient Chinese studied magnetism quite a bit. But it wasn't until 1824 that a British scientist named Sturgeon created his first electromagnet. And he didn't have as many coils as I do here. And his first electromagnet looked like a horseshoe. There's our solenoid. Push that through. And here's our solenoid. And so we're going to try and get all of this electrical coating on this wire off.
really good on one side, not so much on the other. Alright, got that one. Work on this one.
Now you may or may not be able to tell. You see the different colors right here and different color right here. You can definitely see the different colors right here. Well, I just took the coating off of the sandpaper, so hopefully this will work. Here's my power source. Negative side, positive side. Of course, this is a 6-volt battery, so it's not very strong. And now we need something to pick up. Well, since we have such a weak battery, I've decided I'm going to use, let's see, can you see it? Or can you see it? Right there. Okay, little staples right here. So we're going to connect. Be careful whenever you're using stuff like this, because this can heat up pretty quickly. Got our connections. Now let's see if our magnet works. Hey, look at that. Now let's see if it's strong enough to pick up this. It may not be. Yep, well, there we go, right there. That electrical current is making the magnetic field. Now what happens if we break the current? Let's see if we can break the current. Oh, it fell off. That's pretty awesome. Let's try that again. There we go. It may not be strong enough to pick both of these up. There we go. Now this is what happens in one of those car wrecking lots. They pick up the car, they're taking it over to the crusher, and then they cut the power off. Boom. Oh, look at that. We still have a little bit of residual magnetism left. It's kind of like when you get a needle and you put it on a permanent magnet and you rub it and you get a temporary magnet. This is what's happening right here. And then we have our electromagnet.